So imagine a working environment that covers the lifespan of research data products, from design to collection, curation, processing, publishing, and reuse, which enables scientists to focus fully on their research while ensuring seamless data management. FAIR data seems to be the solution for interoperable research. But how to reach this goal? Well, the members of the IADOP working group devoted their time to developing approaches to support research along this path. The main motivation was to promote the use of FAIR terminologies to annotate research data. In 2016, I took over the coordination of ENFTES, the vocabulary for the ELTA, the European Long-Term Ecosystem Research Infrastructure, where I had to steer the development of terms used to annotate what is observed within the research infrastructure. I found this task very challenging, very difficult, as I couldn't find a common approach or grammar to do this in a systematic way. In early 2018, I started the initiative with an ENVI FAIR to collaborate with other terminology providers to define a common practice. This led to the establishment of this working group. And as you can see, the co-chairs are Gwen Moncoffet from the NERC Vocabulary Services, Anu Soria de Varayo from Pangaea, now she's a TERN in Australia, and Maria Stoica she is a co-developer of the science variable ontology. But we also worked very closely together with Siko Schindler from the German Airspace Center and Alison Pammett from the CF Standard Names initiative, and with many others from our quite big membership of the group. We together addressed the challenge of the proliferation of unmapped variable description terminologies, to which we unfortunately all contributed. We could never be sure that the variables that we minted in our terminologies could really be mapped to the variables of other terminologies, because there was no common approach. So while for very simple variables like wind speed, this might be very easy, there are many other challenging variables that are not easy to describe in a systematic way. Therefore, we started to collect user stories from the communities and from different stakeholders, transformed the user stories into use cases, and identified functional requirements from those. Then we also started a quite large survey on conceptual models and terminologies used to annotate data, and identified information requirements from those. And together with the functional requirements, we had a good basis to define and develop the IADOP framework, which we then could test against the use cases and also the feedback we got from the members of the working group. And then we started to develop variable design patterns, which is an ongoing task for the next years. So what do we mean with variable? So there are also other synonyms for that: observable property, parameter, quantity kinds. So the concept variable in IADOP represents what has been observed independently of where, how, and when the data acquisition took place. And this is mainly inspired by the complex property model and the scientific variable ontology that define that a variable can be represented by a combination of descriptive components giving meaning to the value derived from a data acquisition event, be it an observation, a measurement, a simulation, or a calculation. And also important to say is that IADOP only supports the classification of variable types. So we are not really describing a specific observation instance. But let's look at an example and start from there. So imagine we measure the mean concentration of endosulfan sulfate in that flesh of Ostrea edulis, an oyster, at the Emerald Coast in microgram per kilogram. measured in microgram per kilogram. This is the observation. So what is the variable out of that sentence? Yeah, that's the yellow part in the middle. So mean concentration of endosulfan sulfate in wet flash of Ostrea edulis in microgram per kilogram. So we don't address the feature in the SOSA. It's called the feature of interest, not the geographic position, emerald silk coast. That's not our goal. And we are also not addressing the process, the sampling design, for example. Yeah. So we are just concentrating on the yellow part. And we then can imagine that we can atomize this description into the separate elements like mean, concentration, endosulfan sulfate, wet flash, Ostrea edulis, and microgram per kilogram. But then we found out that it is not really correct to say that mean is part of a variable description and also not a microgram per kilogram, because both are not essential for defining what a variable is. A variable should be something reusable, and you could do a lot with these measurements. You can also derive a mean or any other statistical measure. But this is not what we want to address. And also a variable can be expressed in different units. So we decided to not include this in our considerations. And so we leave this to this main concept here, or main atomic parts, and make it really precise. So it's not just concentration, it's mass concentration. As endosulfan sulfate is wet flash and Ostrea edulis. And then the second part is then to identify terms that we can reuse from any semantic artifacts, be it ENVO, for example, that's an ontology, but mostly looking at SCOS vocabularies, thesauri, etc. So this is our task. And was our task, and we developed a framework ontology, which is very simple. So a variable is composed by at least one property, or it is composed by one property and one object of interest. But it could, in addition, involve also a matrix and a context object. And all these three types of entities can have constraints that constrain the value, the meaning of these entities. So let's go to the same example that we have seen before. What is the variable? The variable is the whole sentence, the concentration of endosulfan sulfate in wet flash of Ostrea edulis. The property is the mass concentration. Other examples are abundance, weight, presence. The object of interest is a variable that's the entity whose properties is observed. So, and the endosulfan sulfate, the concentration of endosulfan sulfate is measured here. So the substance. The matrix is the entity in which the object of interest might be contained. In this case, it's flash. Yeah? And the context object is the entity that provides additional background information regarding the object of interest. And that's the species in this case, the Ostrea edulis. And the constraint limits the scope of the observation and confines the context to a particular state. It describes properties of the involved entities that are relevant for that particular observation. In this case, it's the wet flash, but it could also be conditions like at a specific temperature or dissolved or a specific pressure. So all these different components mentioned before are all different types of entities. They get types, they have different roles that they can have in different observations. So an entity may play one of the following roles: object of interest, context, object, and matrix, but they can switch these roles in different descriptions. So this is a specific application for that IADOP variable. How this is done in a SCOS vocabulary. I did it in ENVDES. This is an extension of SCOS. We use the IADOP properties, has property, has object of interest, has constraint, has matrix, and has context object to enrich this term definition. And this is how it would look like. You see that this concentration of endosulfan sulfate in that flash Ostrea aeolis has a broader concept. This is a Scott's property, but it has additional properties like has object of interest that links to a term in the NERC vocabularies, the endosulfan sulfate, the property, the concentration, the mass has matrix, and so on. So I can link from here to any term from any fair vocabulary. So what does this bring? What is the benefit of iAdopt? It supports interoperability between existing terminologies of variables by enabling semantically precise and fair descriptions of variables, and later on also by a service, we are working on this, by decomposing descriptions into atomic components and link those to existing vocabularies. And this makes these descriptions really machine readable and provide abstract, reusable semantic descriptions for concrete observations. And as such, the iAdopt framework acts as a semantic broker, enables mappings between existing variable descriptions across terminologies without changing the original structure, but requiring to add additional human and machine readable descriptions with qualified references. So in near future, we will be able to provide semantic services that propose precise and interoperable metadata that researchers just need to approve or adjust. And this will boost interoperability, findability, reusability of data considerably. And today, data management is mostly perceived and implemented as an administrative burden, but we want to turn common data practices on their heads, and through fair services give the researchers back a majority of their time to science rather than data wrangling. And I think iAdopt will be one of these services. And together with the recommendations, we have also produced some outputs. That's the iAdopt ontology, a catalog of terminologies. We have more than 100 included there for reuse for the iAdopt variable descriptions, and a unit to property lookup service, supplementary material including alignments to other models, design patterns that we are continuously developing, and a set of already of implementations, because quite many vocabulary terminology providers are already using iAdopt, and a step-by-step guide for minting new variables. So I hope we will be able to to foster fair data management with the iAdopt services that we are going to build. Thank you. Yeah, in ENVI Fair, we will have iAdopt framework workshops in March, and we will have many others with Go Fair. Thank you.